All right, so the last section we did, 3.1, was really introducing the idea of congruent polygons, any polygons, right? Pentagons, octagons, whatever. But we are going to really focus on congruent triangles. So 3.2 is starting to look at congruent triangles. Now, there's something really special about a triangle because it only has three sides. It limits the variability of what a triangle can look like. So, like we talked before with isosceles triangle theorem and triangle inequality, when you have two sides of a triangle, this angle, however big that angle is, completely determines how long this missing side is going to be, right? If I take these two sides, keep them that length, and just change the angle, now all of a sudden that other side got a lot longer, right? So there's this direct relationship between angles in a triangle and the sides across from them. And that is going to play a role in congruent triangles. Because like we defined yesterday or the other day, for two triangles to be congruent, all of the corresponding angles are congruent, and all of the corresponding sides are congruent. So if we were going to list all the corresponding angles and what's congruent to what, there would be three pairs of angles congruent to each other, and then there would be three pairs of sides congruent to each other, right? So in these two triangles, let's take these two as an example. We would say angle A is congruent to angle D, and angle B is congruent to angle E, and C is congruent to F. And then side AB is congruent to side DE, and side BC is congruent to EF. Side AC is congruent to DF, right? So there would be 6 pairs of congruent statements we could write. Yes? Remember that? Okay. So here is the good news about triangles. If we are trying to determine if two triangles are congruent, we actually don't need all 6 of those pieces of information like we did 2 days ago. 2 days ago, if I asked you, are these two congruent, you would have to say, well, let me check all the angles and all the sides. But today, we're going to take a shortcut. Because with triangles, since there's only 3 sides, there's only certain possibilities that can happen. So we have these postulates that basically are shortcuts. And this first shortcut is called the side-side-side postulate, SSS. And it basically says that if you have two triangles and you know that the 3 sides of one triangle are congruent to the 3 sides of another triangle, then you don't need to know anything about the angles. Those two triangles are going to have to be congruent. Okay? So, if I gave you all, remember we worked with spaghetti that time, or whatever it was, linguine, right? If I gave you all linguine right now, and I said, everybody cut a 5-inch piece of linguine and a 4-inch piece of linguine and a 3-inch piece of linguine and make a triangle out of it. There is only one way to make that triangle. Connect those together. Whatever those angles are for one person, they're going to be the exact same angles for another person. Since there's only 3 sides, if all the sides are congruent, it automatically makes all of the angles congruent. So what this postulate says is that you don't need to know about all the angles. You could just know the 3 sides, SSS. So think of it this way. Think of it as somebody asking, hey, are these two triangles congruent to each other? And you look at the information you have and you say, let me see. Well, like I said, 2 days ago, you would have to have 6 pieces of information. You'd have to have 3 angles and 3 sides. Today, the shortcut is you would only need to know 3 sides, and you can say, yes, these 2 triangles are congruent. Does that make sense? Okay, the next shortcut postulate is SAS. The S's stand for side, the A's stand for angle. So SAS is the side angle side postulate. This one says that if in 2 triangles, you know 2 of the sides are congruent, 2 of the pairs of sides are congruent, right? So I'm not saying 2 sides on one triangle. I'm saying AB is congruent to DE in this case. And AC is congruent to DF in this case. So 2 pairs of sides are congruent. If you know the A, the angle that's between those 2 sides, then the triangles have to be congruent. So it's very important that on your diagram, the order of where those angles and sides are is in the SAS order. The A here is called the included angle. Oops, wanted that to be yellow. Now it's going to be green. Okay, the included angle is the angle that is actually formed by the 2 sides. So when it says SAS, it really means that on your diagram, you have 2 sides and the angle that's like wedged between those 2 sides. It can't be any 2 sides and any angle. It has to be in the order of SAS, where the angle is literally between the 2 sides. Does that make sense? Okay, so again, if you picture this, the linguine, if I gave you linguine and I said, okay, you have to have a 3-inch piece and a 5-inch piece, and you have to put it on your desk exactly so that the 3-inch and the 5-inch forms a 22-degree angle. If I force you, lock you into those pieces of information, there is only one way to connect that triangle. So if you do it on your desk and somebody else does it on their desk, your triangles will be congruent because of SAS. Does that make sense? Okay. The next one is called ASA. Still the A's stand for angle and the S's stand for side. But in this case now, you've got 2 angles, 2 pairs of angles, right? One angle to another angle in another triangle. And then a second pair of angles, and the side between those 2 angles. So if you look at this diagram here, you're talking about this angle and this angle. There's only one side that connects those 2 angles, and that's AC. So if you think of it as angle A and angle C, the side has to be side AC, right? The side that's connecting those 2 angles. So again, that is called the included side now. Right? So it's really important, the placement on your diagram. 2 angles and the side between those 2 angles. So again, if you lock in that information on one triangle and lock it in to make a second triangle, the 2 triangles have to be congruent. You don't need to know anything about the other sides or the other angle. You can say that these 2 triangles are congruent just with that information. Okay? So that's SSS, SAS, and ASA. So this right here is just defining that included side or included angle, okay, which we just did a little bit. Okay, the last theorem that we're going to learn today is the angle side theorem, AAS. Again, it's two angles and a side, but this is why the placement on the diagram is really important. It's not any two angles and any side. It's two angles, and this time the side not between them. You see here how it's A, and then the S? So this is not the included side. This is two sides and, sorry, two angles and a side not between them. So on your diagram it looks like this. An angle, a side. Now, the side between them would be this one, right? We don't want that one this time. We want either of the other two sides. So in this case, there really is two choices now. We could use side AC, which they have marked here. We could have used side BC, because AAS will work for with either of those. All right. So I know that may seem like doesn't make too much sense yet. This takes practice, and I think as we go along, you'll understand a little bit more about why this makes sense. Okay, so let's turn the page. We're not going to do that. Okay, so I'm going to give you a preview to, yes, proofs. We are going to be writing proofs in this unit. Okay, back to the flowchart proofs. Did I hear a little, yay, yippee? No? Oh, I thought I heard that. No, that wasn't. Okay, I think I saw a few opposites of that. Yep. Yeah. Okay, so we're going to do this one proof just because I think it's important to see what we're heading towards. Eventually, you're going to be writing proofs. We're not going to actually do them today or do them for homework tonight. We're going to do them next time. But the whole purpose of this lesson is going to make more sense if you see what the proof looks like first, okay? So here's some steps for writing a proof of triangle congruence. First, you mark your diagram with the given information. That's the same first step that you've always done. So if we look at this given here, angle A is congruent to angle D. Here's our diagram. They marked it for us. Angle A is congruent to angle D. It's really, really important that you mark your diagram, especially with these proofs. Okay, angle B is congruent to angle E. So again, they did that for us, B and E. And AC is congruent to DF. AC is congruent to DF. Okay, so this particular proof has basically given us everything we need. So there's not going to be a long proof. Some proofs that we'll do are going to require a little bit more than this. But what we're trying to prove is that the triangles are congruent to each other. So it's going to be a common thing that we're trying to prove. Here's this triangle, here's that triangle. Prove that they're congruent to each other. So just like we did before, we're going to start with our givens in boxes, right? Given. Like I said, this particular proof gave us a lot of information already. So with triangle proofs, what you want to do is think about the possible reasons that triangles could be congruent to each other. And that they are the postulates and theorems that we just learned on the previous page. SSS, SAS, ASA, and AAS. Those are the four, so far, the four possible ways to prove triangles congruent. So when we look at our diagram that we just marked from our givens in this proof, which one of those do you think we're going to use here? So there's two angles and a side, right? This is angle, this is an angle, this is a side. Check and see, is the side between the two angles or not between the two angles? Right? You've got angle and angle. Is this side between the two angles or not between the two angles? Not between the two angles, right? So you're correct. It's going to be AAS. Angle, angle, side, not between them. Now, for this proof, it may seem a little silly, but we have enough information to say that already. Those three statements that they gave us for givens is enough to then say triangle ABC is congruent to triangle DEF by the AAS postulate. You could just write AAS. So, like I said, this is a short, basic proof, but you see that every time you prove triangles are congruent, there are always going to be three arrows pointing to that box. Always going to be three arrows pointing to the box that says the triangles are congruent. To the box that says the triangle is congruent to the triangle. And the only reasons that are possible under the box that says the triangle is congruent to the triangle are these four postulates, theorems, right now. There's one more that we're going to learn another day. Okay. Now, you'll notice that in here is a step that we didn't need for this particular proof, but we're going to use it in some of the practice that we do. It says also mark your diagram with any congruence that you know just by looking at the diagram and applying theorems that you know. Most commonly, vertical angles theorem, reflexive property, and sometimes parallel lines like alternate interior angles, etc. So there are going to be times where you are going to be given a diagram and you will know that certain things are congruent. You don't have to be given that information. If there's a pair of vertical angles in a diagram, you can mark them congruent. It doesn't have to be a given statement. Sometimes those other markings that you just know by looking at them are going to be necessary for your proof. This one, they gave us everything we needed. Okay, so let's look at this. Determine whether the following triangles are congruent. If they are, name the triangle congruence. Either SSS, SAS, ASA, or AS, okay? And then make sure that you're showing the additional markings that you used, okay? If you can't prove they're congruent, if there's not enough information, then you just put not possible. Okay, so let's look here. We've got two triangles. We've got this one, and we've got this one. Yeah, sorry, that must have gotten cut off. Thank you. Okay, so triangle ABD. We can't say whether it's congruent yet. We have to determine whether it is. We know that this side is congruent to this side because they told us that. That would be like a given. We know that this angle is congruent to this angle. Again, another given. A really good trick for these types of problems and the proofs is to cover up one triangle at a time. Okay, so for purposes of the video, I'm just gonna, if we cover up one triangle at a time and look at how many things you have marked. So far we have one side and one angle per triangle, right? Is that enough? We need three, right? We need either SSS, ASA, AAS, or what did I forget? SAS. that right? Okay, so 2 markings is not enough. But that's when you look for other things that you just know are congruent because of the way the diagram's drawn. And in this case, does anybody want to guess what we're going to mark? Yep. Okay, actually, that's a really good point. So we could mark A and C congruent. Why? Okay, because this whole thing is an isosceles triangle, right? With these 2 sides congruent. So therefore, the angles across from them are congruent. So we could use that. We could use this and this congruent to each other. All right, if we do that, it's not the one I was thinking of, but I like it. If we do that, then which theorem are we going to use? Again, let's cover up one at a time. We've got this angle, and this side. Which of the, yep, Skylar. Yep, ASA, because it's the 2 angles and the side between them. So that's going to be our reason. ASA is down here. We can say triangle ABD is congruent to triangle. Now, what order would we have to put that triangle congruence in? Yeah, Dom? CBD, because A goes with C, B goes with B, and D goes with D, right? Okay. The congruence that we have here, we said angle C is congruent to angle A. What would be the reason for that? Like if we were writing a proof for this, what would be the reason for saying angle A is congruent to angle C? Good, isosceles triangle theorem. Okay. There's another thing that I kind of want to point out here that we could have done instead. You don't have to erase yours, okay? But since these 2 triangles share this side, do we know that BD is congruent to itself? It's the same side, right? So we could mark that one. So as another possibility, we could say BD is congruent to BD. Do you guys remember that property? It begins with an R. Good, reflexive property. The reflexive property is when these triangles share a side, and it's the exact same segment. It has to be congruent to itself. So BD is congruent to itself, is reflexive property. If we did that, again, cover up one at a time, which would be our reason? Is it still ASA? It's different now. What would it be? SAS, because we've got side and another side and the angle between them. So this would be SAS then. So that's another possibility for this first example. All right, let me switch to another color. All right, so let's look at the next one. All they tell us is that this is congruent to this is congruent to this. Do we have anything else we could mark in this diagram? Yeah. Why? Okay, so the question here says, are these triangles congruent? They're not telling you that the triangles are congruent, right? So if I just gave you this triangle, could you determine how many degrees that angle is? No. Could you determine how long this is? Why? Okay, but if this and this are my two sides, can I make different lengths of the third side? You know what I mean? Right? So basically, there's not enough information here. We don't have three congruences. So we would have to just say, not possible. All right, let's look at this next one. We've got angle N to R. We've got EM to PQ. And we've got EN to PR. So we have two sides and an angle. So our possibility for two sides and an angle, we only have one possibility, and that's SAS. Is this in the right order for SAS? Do we have two sides and the angle between those two sides? If I have these two sides, which angle is between them? E. I don't have E. If I have these two sides, which angle's between them? I don't have P. So, can I use SAS here? No. This would be, don't freak out. That's not a postulate. It's a bad word. Can't use that. That is not a postulate. Okay? So, remember that the bad word doesn't work. Not because it's a bad word, but because this does not guarantee congruence. Two sides and an angle that's not between them actually could create two different sized triangles. So that's why it's not a postulate. So this one we're going to have to say not possible. And although here it was like not enough information, here it's because I'm going to write it backwards just so it doesn't look as bad. SSA is not a postulate. It's a bad word. Okay. There's one other combination of these letters that's missing you might have thought of, and that is AAA. Right? We have SSS. We don't have AAA. Why do we not have AAA? Can anybody think of why? If you have two triangles, let's say 90-degree angle, 60-degree angle, and 30-degree angle. If I make two triangles with those (90, 30, 60), could I make another triangle with those same angle measures that's a different size? Yes. Remember when we talked about dilations, we said the angles actually stay the same. The sides are getting smaller, but I could have two triangles of different sizes with the same angle measure. So that's why you can't have an AAA postulate. These postulates say that if you know all the angles of one triangle are congruent to all the angles of the other triangle, you could conclude that the triangles are congruent. We can't conclude that here. The three angles does not guarantee triangle congruence. So that's why AAA is not a postulate. Okay, so let's go to the next one. Okay, so this is the same directions as before. Are these two triangles congruent? Make sure you're checking that you have 1 to 1, double to double, triple to triple. Are these triangles congruent? What would be our reason? SSS. And the congruent statement, remember the order matters. STU. That starts at S, which is the point that's between the double and triple markings. So what's going to be the first letter from the other triangle? V, right? Because that's between the double and the triple markings. Okay, then they went to T next, which is following along the double marking. So which letter is going to be next for here? X. And then to W. SSS. Okay, for number 5, there's one extra piece of, one extra congruence we could mark just by looking at the diagram. Okay, so good idea. If it was a perpendicular bisector, we could know that it's bisecting the angle. But since this is not marked congruent to that, we actually don't know that that is a perpendicular bisector. The only thing we know is that there's right angles there. That's all we know. But there's one other thing we could mark. Yep. Yeah, YA is congruent to itself. Anytime they share a side, you could do that reflexive property. Does that give us enough information here? Still not enough information, right? So this is reflexive, but still not enough information. Not possible. All right, I'm going to let you do some of these on your own, but I want to point out a couple of other ones first. So remember, anytime they share a side, you can mark it with reflexive property. That's true anytime they share a side, so keep that in mind. But let's look at number 9. What could we mark on this one? Vertical angles, exactly. You could mark this angle congruent to that angle. And then see if that gives you enough information for a use of one of the postulates. Okay, I'm going to pause right here and let you guys practice. Okay, so we're going to talk about a couple of these just to make sure everybody's on the right track. This one, they have a side and a side, a side and a side, and then 2 right angles. Are right angles congruent to each other? Yeah, that's called the right angles theorem, right? They're congruent to each other. So that counts kind of as a congruence. So therefore, we can say CDE is congruent to FGH. And the reason would be SAS, because we have 2 sides and the angle between those 2 sides. Remember, cover up one triangle at a time to look at whether you have all the congruences you need. Okay, my smart bar just froze, and so that's really great. All right, so the next one, number 7. You need to mark this reflexive property, MK congruent to itself. Otherwise, when you cover up one triangle at a time, I'm going to just kind of gray this out, right? If you didn't have this one marked, you would only have an angle and a side, and that's not enough. So you have to mark that middle piece so that in each triangle you have SAS, right? So this one should be SAS. The triangle congruence is MLK. So I saw a lot of people for number 8. They had SSS and they had QPR. That's good, but they didn't have that reflexive marked, which makes me think that you might not be covering up one triangle at a time. You really have to make sure you have all 3 parts marked on each triangle. So you have to mark this, otherwise you don't have the SSS. Right, here we marked vertical angles, but we don't have enough information here because this would be SSA is not possible, right? That's not a theorem. So that's a no. Number 10, we can mark vertical angles again. But once again, it doesn't give us anything possible to use there. SSA is not possible. Yeah. Okay, so K. Yeah, this is a little bit tricky because, okay, because that's a good question. So the question was, how come if this starts with K, this doesn't start with K? Right? Everybody focusing on this for a second, number 7? Because wouldn't K go with K? But in fact, K doesn't go with K. If I drew these separately, J, M, K here, and then M, L, K here, right? And then I marked the congruences. This is congruent to this. This is congruent to this. Right? See, they're marked like that. So, and then this is congruent to this. So, M is congruent to K. So those are the corresponding parts. So it actually is KJM to MLK. Okay? All right, number 11 should be FGE. And the reason is SSS because of that reflexive property again. Now here we have several options. We could mark these vertical angles congruent. We don't even really need to because we have enough to just use SSS. But if you did mark the vertical angles congruent, then you've got all sorts of possibilities. You could do SAS. Actually, these are isosceles triangles, so we could mark that and that congruent as well. So this could really be any of them. SSS, SAS, AAS, could be any of them. All right, any questions on that page? Oh, sorry, yeah. The congruence there should be MLK again. All right, so I'll give you a few more minutes to do more on the next page. So I'm going to go over a few of these. This one is going to be not possible. Not enough information there because we don't have any reason to mark anything else. 19. Number 20, we can mark reflexive property. Again, then cover up one triangle at a time, and you see that you have 2 angles and a side marked in each triangle. The side is actually between the 2 angles, so it's going to be ASA. And the order should be UVT. For number 21, the one thing you can mark is the vertical angle pair. That's all. Now cover up one triangle at a time. There's 2 angles and a side, but this time, is the side between the 2 angles? No. So we have AAS. 22. Be careful because I see a lot of people marking sides congruent for really no reason. You have to stop yourself and say, if I was writing a proof here, what reason would I give? Right? Up here, we would say reflexive property when we marked that. We have a reason. Here we would say vertical angles theorem. We have a reason, right? Down here, vertical angles theorem is the only thing here. We can't mark any sides congruent. Cover up one triangle at a time. Again, we have 2 angles and a side. So it's either AAS or ASA. Which one is this one? AAS, because the side is not between the two angles. This one should be, well, actually, we don't even need to do that because this is not enough information. You can mark the vertical angles, but it still doesn't give you enough. This one, we got nothing else to mark there, so that's not enough information. 25, they've already marked enough for us to give a reason here. What would be the reason? ASAs, correct? What else can we mark here? What would be our reason for marking that? Reflexive property, right? Reflexive property. And then, is there enough information to give a triangle congruence? Nope. Here we've got all sorts of things we can mark. What does this little arrow and this little arrow mean? Parallel lines, which means we can mark alternate interior angles congruent. This, by the way, I sometimes call this the hourglass, or if it's turned the other way, the bow tie. Remember, we've talked about this before. Sometimes it's actually a very common diagram, and sometimes the lines are parallel, sometimes they're not, but you got to kind of look for that possibility. So if they're parallel, angle D and angle G would be congruent, but so would H and F. Those are alternate interior as well. We also have vertical angles. So we have all sorts of possibilities here. EHD would be the order. This would be either ASA or AAS, depending on which angles you want to use. Okay, this next section is a tiny bit different because they're giving you given information and they just want you to mark it. So once you mark the diagram, then it becomes exactly like the section you just did. But here, you know, DE is congruent to BA. You need to make sure you know how to mark that. DE is congruent to BA. It might not look like what you thought would be marked congruent to, but you have to follow what they gave you. And then angle B is congruent to angle D. Angle B congruent to angle D. Now, what else could we mark in this diagram? Vertical angles. Now, this is a little tricky because if you cover up one triangle at a time, what postulate does that look like? For this one, two angles and a side not between them, right? That's like AAS. But let's look at the other one. What does that look like? ASA. They don't match. So not possible, right? You can't have it be two different things. They have to be the same for both. All right, I'm going to skip down now. I'm running out of time a little bit. I'm going to have you skip number 32 for now. And I'm going to have you turn to the back. And I just want to do one or two of these. These are basically giving you really, really basic proofs that are, and they tell you what you're going to use. It's basically an example of each type. So for this one, they give us that LM is congruent to NP, and that's already marked. LP is congruent to NM, and that's already marked. They want us to use SSS. What they give us in the given is not enough. So what other reason would we have to give? In other words, what else could we mark in this diagram? Say again? Reflexive property, right. So this is given, this is given. We have to add that other piece that we know we can mark. We have to put that into our proof. So LN is congruent to LN. Our reason, that's not given, our reason is reflexive property. But now, do we have enough to say that the triangles are congruent? Yeah. Again, always 3 arrows coming down to your statement of triangles being congruent to each other. Triangle LMN, congruent to triangle NPL by SSS. Yep. Okay, I'm going to skip numbers 2 and 3 and go down to number 4. Start with our givens. Angle M is congruent to angle K. They have it marked for us. And then look what they tell us. WM is parallel to RK. And they have these arrows here. If these two things are parallel, we should be looking for alternate interior angles or corresponding angles or something like that, right? So remember the Z. So because these two are parallel, those have to be the top and bottom of our Z. We could say that this angle is congruent to this angle. Yeah, we're going to do that too, yep. But from this given, that the lines are parallel, we could say that angle KRW is congruent to angle NWR. Sorry, MWR. I had it covered up. I couldn't see my letter there. MWR. KRW is congruent to MWR. This one congruent to this one. Now, the other thing we can mark in this diagram is reflexive. If we mark it in the diagram, we have to write it in our proof. WR is congruent to WR by reflexive. Now, do we have enough to prove the triangle's congruent? And what postulate would we use? Angle, angle, side. We got this angle, we got this angle, we got this side. And if you cover up one triangle at a time, you see that the side is not between the two angles. So it's ASA. So you would say triangle WMR congruent to triangle RKW by AAS. Okay, just a little word about this reflexive. I'm not going to be picky about the order that you put them in, so I wrote WR is congruent to WR, just not to confuse anybody. It's really more correct in this one to say WR is congruent to RW. Because if we did the triangle congruence, look, WR first to last, and then R to W first to last. So I'm not going to be picky about that, but just something to notice. Okay, so yeah, your homework is to finish this packet. You should be almost done with it, right? There's just probably a few left to do. So there's the 2 proofs that we didn't do, and then the, I know I said there wasn't going to be proofs for homework, but these are really simple ones, so I want you to give those a try.